Hello dear students, and once again I welcome you all to the course on kinematics and theory of machine. So in this lecture we are going to start the third module, which is basically about cam and follower. So this cam and follower, it's a kind of very useful kind of mechanism. So we'll see how it works. So and what are the different classification, etc., what are the different types of movements that is possible, what are the how we are going to design a particular cam suitable for a particular type of record motions and all. Okay, so from the previous knowledge what we already know, we have already from the in the case of first module we have already discussed about some higher pairs and all. Okay, similarly we have discussed about close kind of, you can say, close type of you can say close pairs and all. Okay, so there we are already familiar with the term cam and follower. Okay, so now this cam, so how can we define cam? So basically it's cam, generally it's a rotating mechanical element which mostly provides either rotating or reciprocating or oscillating kind of motion to another element which is attached with it, and that particular another element which is attached with it, which is in contact with the cam, is known as the follower. So in general this cam and follower, both of them, okay, so the cam and follower, one is the follower, one is the cam. Okay, so they generally constitute that particular required mechanism which we use for transferring motion and all. Okay, so later on we'll see how it can be used, what kind of motion we can generate and all. Okay, so as we already know, there are multiple ways of getting the motions. Okay, maybe even by the use of can say motors we can get motion. We have seen different mechanisms available, like slider crank mechanism. We can get different maybe from rotational motion of the crank to the reciprocating motion of the slider we can get. Similarly vice versa also is possible. We have already discussed about different intermittent motion mechanism, etc., etc. So now, as we already have different type of mechanism, so then why this particular another mechanism, cam and follower mechanism? Okay, so why this particular thing is important, why it is in use, or why it is important? Is it only for making increasing the complexity or to increase the syllabus and all? So definitely no. So the use of this cam and follower, later on you'll see, and now also we are going to discuss. Okay, so it's basically different complicated output motions which generally are not possible to obtain by the normal whatever the type of motion generation we are that are available it has. Okay, so whatever is generally not possible to obtain with it, so that kind of complicated output motion as per our requirement. So to get that kind of motion, it's possible we can get the motion by the help of that kind of desired motion, which are generally complicated to get by other means, by the help of cam and follower mechanism. Okay, so now if we come to this particular animation, okay, this one you will basically see this cam which is operating and a particular knife edge follower that is there. Okay, so in this particular animation, so this part, okay, this is nothing but the shaft. Okay, rotating shaft, it's the rotating shaft on which this particular blue part, this is this is mounted on the particular shaft. So in this particular case, the shape of this particular blue part is something like this, and suppose this is the axis. Okay, so this is the axis, so this is this one. Okay, so that means from this side, if I view from this side, so it will move inside this particular plane, it will insert it inside the particular plane. So now this particular part which is having rotational motion, as we already can see, it's already being mounted on that particular rotating shaft. So along with this particular part will have the rotational motion. Okay, so this particular part is nothing but this particular cam. Okay, it has, as you can see, it has got a specific contour, a specific shape has been given. Later on we'll see what are the different parameters and all, how to design the or shape that particular cam profile. All those things we'll discuss later on. Okay, now you just understand how it is basically working. So now as you can see, it has got three basic elements. Okay, one is this particular cam. Now you can see another element, that this one, okay, which is in contact with the surface of this particular cam. Okay, it is somewhere here. Okay, it is not embedded. this is rotating cam. Okay, as you can see, this is the cam, and you can see this particular element, the sky blue part, okay, which is in contact with this particular cam which is rotating, and along with it, as it is in contact, it is held in the contact is maintained around the cam. So basically, depending on whatever is the shape of this particular cam and at what rate the cam is rotating, what is the angular motion and all, depending on that, this particular follower is getting certain motion. Okay, so it is getting the motion from the cam. So now in general what happens, so in most in practice, okay, this follower motion is basically guided, so it is constrained to move only along a particular direction. So generally we have a guide here, so this is the guide we'll have, or the frame, okay, guide or frame. So this is the follower, okay, this is the follower, and this part which is rotating in most of the cases is the cam. Okay, so three basic elements if we can discuss. So this is the cam, okay, we have the follower, we have the guide or the fixed frame. Okay, so this is nothing but the fixed element. So as you can very easily see from this particular figure, so as our follower is in the contact with the particular cam, so along with the movement of this particular cam, whatever be the shape of this particular cam, depending on the shape, okay, the on the particular surface of the cam, basically the follower is always in constant contact. We want that it should be in constant contact, we don't want that contact should be broken and all, otherwise transmission of the motion from this cam to the follower will not happen. Okay, so that is there. So now from this particular discussion, all of we can very easily discuss, so which part of this particular mechanism is the driver, which is the driven part. So very easily all of we can say the cam is the driver, so follower is the driven. So that means from the cam, follower follows the cam. Okay, whatever be the motion of this particular cam, similarly whatever be the shape of this particular cam and all, based on that follower gets the motion. So this cam, it's kind of the input, the follower, it is kind of the output. Okay, so this is the input, this one is nothing but the driver. Okay, this is driver, and this part is follower is driven. So basically we don't use the word driver and driven, but it is working like this. Okay, the thing is input motion is we mean on this particular cam, output we get this on this particular follower, and wherever in the other part of any mechanism or any other part, so wherever we record this kind of, suppose this kind of reciprocating motion and all, we can connect this particular follower to another element from any mechanism, any wherever it is required and all. Okay, and that particular part will be operated with the help of this particular cam and follower mechanism, where we can design the cam as per our requirement, because we have seen that the follower motion, it is dependent on the cam surface. So how they are in contact, if suppose the cam surface is something like this, cam shape is something like this, and suppose the cam is something like this. Okay, so different figure shapes of this particular cam is possible, you can design as per your requirement. So in those cases, in both the cases, if we use a particular suppose follower, okay, so later on we will discuss about the different classification of follower. So in this particular case, this is a knife edge kind of follower, because the contact is something like this, like the knife edge. So in this particular case, in both the cases, so depending on the position of this particular what is the position of this particular cam at a particular point time, so based on that the contact of the follower will be there along with this particular cam surface, and at a particular point, whatever be the position of this particular cam, based on that we are going to get the movement of this particular follower. Okay, now suppose it will be here, so after some time when it rotates and assumes this position, then the follower will come down to this particular position. Similarly, there will be a time when it will rotate like this and assume this particular position, then once again follower will come back like this. Similarly, once again this particular like this it will happen, it will go up. Similarly, there may be a time when it will be like this, once again it will be like this. So the contact will be there along with the cam and follower surface. So as you can very easily see, so the follower depending on whatever be the shape and size of shape and movement of this particular cam. So the follower is going to get the motion, and generally based on it, so basically what is happening, so we have seen that follower is sometimes coming down, after that once again in the cycle maybe it is going up and like that, and if we consider multiple cycles it is reciprocating like this, up and down movement will be there. Similar is the case in this particular case. Okay, so you can see that follower is going down, follower is going up. So based on that we will discuss about the different strokes of the follower. We'll see return stroke, that is coming down. Okay, we'll see the right stroke when the follower is moving up, and so on. Okay, I hope you have understood. So similar is the case. So here also you can see you can see in the second figure what we are doing, we are showing in a particular shaft. Okay, so it's possible to have multiple cams on a particular shaft, which in turn can operate multiple followers. Okay, and these followers, as later on it will be evident, that means these followers may be in different shapes. Okay, and the output motion from the follower can be used to operate different, maybe it may be some valves, it may be some other elements and all. Okay, so right now in this particular figure you can see that basically on a particular shaft this 1 and 2 numbers of cams are there, and along with it, so these golden parts we already have, these are nothing but the followers. Okay, it is being operated like that, and as it is evident from this particular figure, particular animation, so you can see here also these two shapes are like X shape. Okay, these cams are like X shape. Okay, but if you can if you properly see, okay, so this basically they are positioned in a different way. Okay, suppose one position is something like this, another is at this particular location, suppose like this, you can consider, you can see. Okay, so in that particular case what happens, if you see the operation or movement of this particular follower, which in turn is considered like a just like a valve. Okay, so you can consider as if it is operating some valves. Okay, so in a particular timely manner what basically is happening, whenever this cam is rotating like this, and this portion, bulging portion, is just coming in contact with the follower, so basically along with this portion, so force transmission is taking place, and in this particular direction it goes down. Similarly, when the surface contact will be always there, and when the other portion comes, then once again it goes up. Similar is the case with this, but you can see they are being, as depending on how the position of the or orientation of the cam is there, based on that at different times. Basically, if you consider this is one valve, suppose this is another valve, so both the valves are operating at different times. But if you see both the shapes of the cam, it is same. So as the shape of the cam is similar, so later on you will see how the shape actually basically the shape actually gives the whatever is the motion, it determines the motion of this particular follower. So in that particular case you can see the type of motion that we are getting on the follower is similar, but we are getting the motion in different time. Okay, so those kind of possibilities are also there. So similar kind of motion at different places you can have at two different intervals, that is possible. Similar is the case. So you can see even though the cam is having continuous movement, so what you have seen, for a particular time period only the cam is, suppose the follower is moving like this, after this for the rest of the movement of the cam it's showing like that, after that once again periodically similar kind of motion it is repeating. So it's a kind of a somewhat complicated motion. You cannot say about different type of mechanism which can give rise to this kind of motion, but very easily with the help of by designing a cam properly we can very easily obtain this kind of motion. Okay, so now the question comes, we have already discussed about all those higher pair, lower pair, etc. So now this cam and follower, okay, is it constituting higher pair or lower pair? So basically if you can recall what is higher pair, what is lower pair, so in this particular cases you can see that the cam and the follower, they are definitely in contact. Okay, and based on actually what type of follower is there and like that, so most of the time they actually make point contact. Point contact means actually line contact it makes if you consider a 3D. So we already know point contact or line contact between two links. Okay, the elements basically gives rise to higher pair. So all of you can very easily now answer whether they are making higher pair or lower pair. Okay, Next, some of the application of cam and follower. So it's utilized in various mechanical elements to give rise to machines and all, to give rise to different kinds of complicated motions, complicated output motions, mostly the time varying type of motion. Okay, and time varying type of motion means time, like suppose in a particular time, suppose I want this kind of motion, after that suppose for a particular period I don't want any kind of motion, maybe after that there should be some motion and all in a particular fashion and all. So in those kind of cases, so in the time wise, okay, whatever kind of motion that you want, that kind of time wise fashion motion we can generate with the help of properly designing a particular cam, okay, and using it with a in accordance with a particular follower. Okay, so the uses in different cases, okay, maybe in automobile machine, automatic machines, in different in the IC engines for operating the different valves in different machine tools, etc. Those are some of the application area of cam. Okay, now once again you can see different cam example. So just like in the previous case, we have seen two cams were mounted on a shaft. So basically that can in different cars and all in automobiles, you can see one shaft known basically as the camshaft. So it is already there in the so you can see this is one cam, another cam in a similar fashion it is mounted. Similarly, this another cam, this one is cam, okay, like that. Okay, 6 cams very easily you can see. So this kind of shafts where basically multiple cams are mounted, and it is used to operate different parts, mostly the valves and all. Okay, so that is known as, this particular shaft is known as the camshaft. You can see it's what we have shown here. That means orienting the cams of same shape, okay, which are mounted on the same shaft, okay, which is will be rotating with the suppose same angular velocity and all, but they are positioned differently, their orientation is different. So in that particular case, you can expect that if the design of the cam or the shape of the cam is similar, then you can expect similar fashion of motion you will obtain, but at different time. Okay, because we can see that different surface, different shape of the surface will come into picture or come in contact with the follower at different times. So based on the whatever be the shape, whether the distance of this particular follower point is changing at that particular contact period of this particular cam and follower, so based on that basically there will be the motion of the follower. Okay, now in this particular animation you can see we are showing in a particular internal combustion engine a cam follower. It is basically operating the inlet exhaust valve. So all of you already know, if we are talking about suppose from the previous knowledge, suppose 4-stroke engine, then we know suppose what are the 4 strokes available. Okay, suction, compression, expansion, exhaust. Okay, so in those cases we already know there is some requirement of fuel intake, and similarly during exhaust and all we have to take out the exhaust gases and all. So in those cases you know that there are certain valves which are there. The valves opens, suppose the valve has to open so that we can like the insertion of the required charge, that is the fuel, it can take place inside the cylinder. Similarly, after that what should happen during the suction period, basically it should open and we should be able to like inside of the cylinder we should be able to like fill in with the charge or the fuel. Okay, next, like during the other time, basically during the compression stroke, similarly in the expansion stroke, etc., we want that the valves should be, it should remain closed. And after that what do you want, we want that once during the expansions, after the expansion stroke is over and all, okay, towards the end of this or in the exhaust stroke, basically outlet valve should open so that the exhaust gases and all, okay, it can leave that particular chamber. So this is the kind of periodic motion that we want, yes or no? So in this particular case our requirement is something like this. So the valve, if we are talking about, suppose if we consider the two valves which is shown with this. Okay, so basically this one, this gray part, they are the two cams which are responsible to give the motion to the two valves of this particular engine, if we consider this. So the green parts, the two green parts, these are nothing but the follower which is in contact with the cam, constant contact is there, and the motion of this particular follower is given to this particular blue extension part, which are nothing but the, you can consider the, they are operating the valves, they are the valves. Okay, as you can very easily see here. So the valve is resting on this particular seat and all. Okay, when the valve is downward position, in the downward direction, the valve like when it is closed, okay, opening is closed, and similarly when it goes up it opens. Okay, so that means the opening and closing it is taking place like this. Now you can say our requirement is like this. So what is our requirement? So we want that basically during the course of a section what should happen. So my valve, it should first open so that I can take in the surge. Okay, next it should open so that I can take in the surge. Okay, next for other time, okay, during the other stroke it should remain closed, it should not open. Okay, and after that during the suppose exhaust and all, once again it should open. Okay, so that kind of requirement is there. Okay, similarly if we operate both the valves in a different way, okay, maybe one exhaust valve, one inlet valve, so there is the cases suppose at this portion time it should open, then it should remain closed for the other duration, then once again whenever the required stroke comes it should open. Similarly if you consider the exhaust valve, okay, maybe it should remain closed during the other duration of time, and during the exhaust stroke it should open so that like the exhaust gases, the flue gases can eliminate the, then can get out of this particular chamber. So this kind of requirement is there, right? Time varying. So valve it should open, next it should remain closed for some time, once again it should remain open for a certain amount of time. So it's a time varying, and it is kind of intermittent also as per your our requirement. So this kind of complicated the time varying kind of motion can be very easily obtained through the help of this cam and follower mechanism. Okay, so we can design the cam in such a way that there will be, later on we'll see how basically based on the distance from that particular center and all, so how whenever it is varying, how basically the cam is getting the motion and all. Okay, so basically by properly designing this particular cam profile, that is the shape of this or the contour of this particular cam, so we can play with, basically we can know where will be the position of this particular follower. Okay, and depending on whatever is the follower position, we can know whether if we are talking about a valve, whether it will be in open position or it will be in closed position and so on. Okay, so in the next classes we'll be discussing about the classification of cams, classification of follower, different motions and all, and I hope how this cam and follower mechanism, can and follower mechanism works. So in this particular lecture it is clear to you. So thank you everyone.